Hi, my name is Venkarna Kota. Today I want to discuss a reflection coefficient of transmission lines. So here reflection coefficient is defined as the ratio of reflected voltage to the incident voltage. Ratio of reflected voltage to the incident voltage. So V suffix R is the reflected voltage, V suffix I is the incident voltage. In terms of current, rho reflected coefficient rho is equal to reflected current to the incident current. The ratio of reflected current to the incident current. So this is known as reflection coefficient of current, and VR by VI is known as reflection coefficient of voltage. So reflection coefficient is a vector quantity. It has a magnitude and as well as direction. So here negative reflection coefficient, current reflection coefficient is negative and voltage reflection coefficient is positive. So here the main difference is reflected current, incident current and reflected current both are opposite directions. When the directions are opposite, the negative minus is indication opposite directions in the current. So that's why reflection coefficient of current is negative. Reflection coefficient of voltage is positive. So that is indicated as rho is equal to minus IR by IA and rho is equal to VR by VI. And now the matter here I want some kind of instant wave or reflected wave. So this is the input port term and this is the output port. So from the input to the output waves are traveling, then that waves are known as incident waves. When the waves are traveling from output to the input, then that waves are known as reflected waves. So the reflection coefficient is the ratio of reflected wave to the incident wave is known as reflection coefficient. So reflection coefficient can be derived from the fundamental transmission line equations. So here fundamental transmission line equations. Fundamental transmission line equations are V is equal to A into exponential minus Px plus B into exponential plus Px. And similarly, I is equal to 1 by Z naught A into exponential minus Px minus B into exponential plus Px. These two are known as equation 1. So these two are fundamental equations of transmission lines. So from these two equations we can derive the reflection coefficient equation. So here in this equations, first term, this is the first term, A into exponential minus Px and A by Z naught exponential minus Px. These are first term. This is the second term. First term here, first term indicates incident wave. First term indicates incident wave. And second term indicates reflected wave. In the fundamental equations of transmission lines, V is equal to A into exponential minus Px plus B into exponential plus Px. So in this A into exponential minus Px indicates, first term indicates the instant wave and B into exponential Px indicates the second term indicates the reflected wave. So here let V and I are, these two equations are fundamental transmission line equations. So from these two equations we can derive the reflection coefficient. let y is the distance from output to the input. So for example, it is a input port, this is the output port. X is the distance from input to the output. Then y is the distance from output to the input. So the distance is same, but directions are opposite. So that's why x is equal to minus y. So here let y is the distance from output to the input. Output nunchi input ki distance y anukunnataithe x is equal to minus y avutundi. So then x is equal to minus y, substitute in above equation 1, then we get so here input to the output, x is equal to, x is the distance from input to the output and y is the distance from output to the input. So therefore x is equal to minus y. Then x is equal to minus y, substitute in the above equation b and I, then we get v is equal to a into exponential py plus b into exponential minus py, and I is equal to minus z by minus I is equal to 1 by z naught a into exponential py minus b into exponential minus py. Then if y is increases, then incident wave is increases, reflected wave is decreases. Reflected wave is decreases. Then at for example boundary conditions, at y is equal to 0, when y is equal to 0, substitute v is equal to vr and I is equal to ir. So y is equal to 0 means this is the input, this is the output port. So y started from output to the input. So that's why at y is equal to 0, that is exactly at the output port only. At the output port, the voltage equal to output voltage VR. At the output port, current equal to output current IR. So therefore, in the fundamental equations, in the place of V, we have to substitute VR, and in the place of Y, we have to substitute Y is equal to 0. In the place of Y, we have to substitute I. In the place of Y, we have to substitute IR. Then VR is equal to A into exponential minus P of 0 plus B into exponential P of 0. Similarly, exponential minus P into 0 equal to P into 0, 0. Exponential P into 0, 0. So therefore, VR is equal to A into exponential minus 0 plus B into exponential plus 0. So exponential minus 0 is equal to 1, exponential 0 is equal to 1. So therefore, VR is equal to A of 1 plus B of 1. Then we get VR is equal to A plus B, equation 2. Then similarly IR is equal to 1 by Z naught A into exponential P of 0 minus B into exponential minus P of 0. So then 1 by Z naught exponential p of 0, exponential 0 minus p exponential minus 0. So here exponential 0 equal to 1, exponential minus 0 equal to 1. So that's why the above equation is written as 1 by z naught a of 1 minus b of 1. So then the above equation is written as 1 by z naught a minus b. So IR is equal to. So here z it is the a minus b is equal to z naught into IR. This is equation 3. So from equation 2, a plus b is equal to VR. From equation 3, a minus b is equal to z naught into IR. Then addition just same avutundi. After that p b cancel, a plus a 2a is equal to VR plus z naught into IR. Then a is equal to VR plus z naught into IR by 2. This is the equation 4. Then similarly B. So in the above equation, a plus b is equal to VR, a minus b is equal to z naught into IR. So minus plus minus. So cancel a cancel. 2b is equal to VR minus z naught into IR. Then b is equal to VR minus z naught into IR by 2. This equation is 5. So here final equation A is equal to VR plus z naught into IR by 2 and B is equal to VR minus z naught IR by 2. So then the reflection coefficient is equal to VR by VI, and reflected voltage to the incident voltage. So from the equation V is equal to A into exponential Py plus B into exponential minus Py. So this is the first term is the incident wave, second term is the reflected wave. So that's why rho reflected coefficient is equal to reflected wave B into exponential minus Py by incident wave A into exponential Py. So then the above equation is this is written as B by A into exponential minus Py into numerator coming to the, so here denominator exponential Py coming to the numerator. So then exponential minus Py. So when the bases are equal, so these two are added. Then reflection coefficient is equal to B by A into exponential minus 2py. If y is equal to 0, rho is equal to B by A exponential minus 2p of 0. Then B by A is equal to exponential minus 0. So exponential minus 0 is equal to 1. Then rho is equal to B by A. So B is equal to, in the equation we have to substitute value of B. So here rho equal to B by A. rho is equal to B by A. So what is the value of B? Value of B is equal to VR minus Z naught into IR by 2. What is the value of A? VR plus Z naught into IR by 2. 2 cancel. Then the remaining value rho is equal to VR minus Z naught into IR by VR plus Z naught into IR. So in the numerator we have to take IR is common. Then VR by IR minus Z naught by, here in the denominator also we have to take IR is common. Then VR by IR plus Z naught. IR both are cancel. Then reflection coefficient rho is equal to VR by IR minus Z naught by VR by IR plus Z naught. So here output impedance ZR is equal to VR by IR. Then in the place of VR by IR we have to substitute ZR. Then the reflection coefficient is equal to ZR minus Z naught by ZR plus Z naught. So finally the reflection coefficient is equal to ZR minus Z naught by ZR plus Z naught. This is the reflection coefficient equation. So this is the reflection coefficient of transmission line. ZR minus Z naught. ZR is the output impedance minus Z naught. Z naught is the characteristic impedance plus, here ZR minus Z naught by ZR plus Z naught. This is equal to reflection coefficient of transmission line. Thank you. For more updates, for daily classes, definitely subscribe my channel Electronics for Gate by Kota Venkanna. Thank you.